This is John Black, super chemist, here to make some gun cotton, nitrocellulose, cellulose nitrate, has a lot of names. Alright, I wanted to go over some safety stuff. Normally I'm not that good on safety, I don't go over it that much, but in this case I have to. I mean, this stuff is very dangerous. I wouldn't make, if I was going to make some, this first time you're making some, I'd at least make something small. I don't suggest anyone make this stuff. And if you do, I definitely, even I don't store it. I would not store it. It could go on, even if you clean it perfect and you do everything just right, you still have that chance that it's going to go off. And the thing is even if it doesn't go off, the stress of thinking of it, I mean, it's not like going to blow up your house or whatever unless you make a really lot, but it's going to make a big flame, and that flame could catch something on fire, which in turn could catch your house on fire, and you could be sleeping and you wake up dead because your house burned down. You know what I mean? So I just wanted to go over that this is for educational, really. I do not suggest anyone make it, and definitely do not store it. You know what I mean? If you're going to make a little quantity or whatever, just to see what it's like or whatever, write it off that as soon as you make it and you dry it, you got it, whatever. Do not, wait around, for a month or something to set this stuff off. Either use it or don't make it. You know what I'm saying? You shouldn't make it in the first place, really. I can't stress this enough. If you do it on your own, it's on you if you blow up. Keep in mind, nitric acid does catch most gloves, like latex and nitrile. I think pretty much all the gloves. Flyer, you have to have special gloves for it, or use your hands, and then you got to be watched so you don't get none on your hands. Definitely use goggles and fume hood. This thing puts off so much fumes while it's being made that it's unreal. You have two acids that are fuming out of the reaction, and like I said, at any moment this stuff could detonate, self-detonate by itself. So I just wanted to put this disclaimer up. It's a nice science for actually making it. Like now I got to be all paranoid because I got to wait 24 to 48 hours for this stuff to be done. And if I just had like 10 cotton balls, I wouldn't care. But I got a whole mole up there almost, and that's scary because I don't even know if I'm going to be able to go to sleep. But I just wanted to let you know, if you do anything, you do it at your own risk, your own whatever. Don't blame me if you blow up or you catch your house on fire. This experiment should not really be done by people, you know what I mean? I'm just doing it this once. I've done it before a few times, so it's not like I don't know what I'm doing. I've done smaller quantities, obviously. I didn't just start out with a whole mole. So keep that in mind. As you can see, all I did was put an NO2 where I took the H off and I put an NO2 on. There's your nitronium ion. That's nitrocellulose. Okay. This is the formula right here. Now, just because this is the formula, it doesn't mean that's the stoichiometric amounts that you should use. Okay, so according to the equation, this is a catalyst. But we'll get into that in a bit. You need 3 moles of nitric acid, 1 mole of cellulose, and you get your nitrated cellulose, your nitrocellulose, and 3 waters, right? Now, these are your molar masses or molar volumes. This is the cellulose. I only have 128.45 grams. You can see that's less than a mole. But you want to add in extra. You know what I'm saying? You don't want to add in exactly this amount because you won't get a nitration. You won't get a full nitration unless you're nitrating twice. Now you're supposed to do this procedure twice. You nitrate it, then you clean it, then you nitrate it again, right? In doing that, you only use 3 moles of this, 1 mole of this, and you use 1 mole of the 3 moles of the sulfuric acid, because you want these to be equal. Even though this is a catalyst, you want them to be equal. Since you're nitrating it twice, you would only use what I just said there. You don't have to try to put in a little bit extra, because the second nitration will take care of the part of the cellulose that didn't get completely nitrated. Okay? But I'm not doing it twice. I'm only going to do it once, which is improper, the wrong way. But it takes a lot of time, a lot of chemicals to do this. I'm like, it's good enough. I'll just add a little bit extra in. So anyways, I took this times 3. How did I get this? First of all, I went to the Wikipedia, got the molar mass, divided by the density that they gave me. I got 42 milliliters. I need 3 moles, so I times that by 3. So I need 126 milliliters, okay? Concentrated, not concentrated, fuming nitric acid. But the problem here is that I need to do this experiment with 70% concentrated nitric acid. Okay, so what I do down here, again, I went to Wikipedia, got the molar mass, times it by 3. That's 189 grams is what this weighs. This 126 milliliters I need weighs 189 grams. Now, if I want 70%, right, this would be the 70%, right? So that means that if I divide this by 7, I would get 7 parts, and then I want the other 3 parts would be water. So I times it by 3, right? Divide this by 7 to get, because if this is 70% and I divide by 7, I'll get 10%, right? So when I divide that, I'll have 10% of the total thing. And we know that 30% is water. So I times it by 3, because if this is 10%, times it by 3 would be 30%. So I have 81 grams of water. Grams is the same as milliliters when it comes to water, right? So I need 81 milliliters of water, 126 milliliters of nitric acid, and to mix them together, right? Alright, so for the sulfuric acid, again, I go to Wikipedia, I get the density and the molar mass, I divide them. I get 53.6 milliliters per mole. I'm guessing that my drain cleaner is 95%, so I divide by 0.95. I get 56.41 milliliters. Now remember, we had 3 moles of nitric acid. Even though this is a catalyst, we still want to put a 1-to-1 ratio. Okay, you want all of the nitric acid to be able to be nitronium ions. You don't want the nitric acid to wait for the catalyst to replenish itself to get to the next night. You want it all to be NO2s, positives. So you want an equal amount. I got 3 moles of the nitric acid, so I times it by 3. I'm going to add 169.23 milliliters of sulfuric acid, right? Now if I add that up with the other 200 milliliters of water and nitric acid, it's only 370 milliliters. I already put the cotton inside the glass container that I'm using. I need at least 500 milliliters to cover it up, okay? So I'm going to add in another mole of sulfuric acid as filler, right? I don't want to get down to 2 or 3 nitronium ions and they're way over here, and the part that needs nitrated is over here. I want excess in there so it gets a full nitration. Keep in mind, you're supposed to do this twice, technically. I'm only going to do it once. So, that right there, you know what I mean, I don't want to put a lot of excess in. So anyway, so that comes out to 223 milliliters of sulfuric acid. That's what I will add in, okay? But if I do that, I'm going to have to I'm going to have to add some more, I'm going to add another mole of nitric acid, right? So that I can get, if I add sulfuric, I might as well add the nitric and get some more nitronium ions in this solution, right? So since I added that extra mole of sulfuric acid, I'm going to add an extra mole of nitric acid, right? To do that, remember I got 126 milliliters of nitric acid, a mole is 42, so I just add them together to put in an extra mole, right? 168 milliliters. Of course, that's going to change my water content, right? So if 63 grams is 1 mole of nitric acid. Again, I divide by 7 so I can get what 1/10 of the total is. And there's 3/10 or 30%. So I times by 3, I get 27 grams. I add these two up, 81 plus 27, I get 108 milliliters of water. So I'm going to do 108 milliliters of water. I'm going to add 168 milliliters to that. I'm going to freeze it, and then I'm going to add my 223 milliliters of sulfuric acid to that. I'm going to freeze it again, and then I will nitrate my cotton. Okay, so the first thing I need to do is make my 70% nitric acid, right? I need to put 168 milliliters of nitric acid into 108 milliliters of water. Alright, I got most of the water in there, but I saved a little bit just so I can wash out the thing when I'm done here, the acid. Here's the acid. Whoa. Well, that's it. I got 70%. Alright, I got my nitric acid in here. Got an ice bath. And I'm just gonna do this slowly. Everything's down to minus 10 degrees Celsius at least. You got to do this very slow. You want to add the sulfuric acid to the nitric acid, but you want to keep it at 0 degrees. So I'm just gonna, you can drip it in. I'm just gonna add it little bit by little bit. Keep track of the temperature. Now I got my nitronium ion.